Okay, let's take a look at our first PowerPoint, and that's Introduction to Digital Electronics. That word digital is key, and we're going to look at what exactly that means. So the question then is, what is digital devices? Well, a digital device contains a discrete or an exact value. Okay? And that exact value is usually a 0 or a 1. And you've heard of this system before, probably in PoE, and that's called binary. So binary uses zeros and ones to represent values. So why are there so many digital devices today? Well, throughout history, electronic devices were analog. So an analog signal is not 0 and 1. It is not discrete. It has many different values. Okay? Well, nowadays, basically everything is just about digital. Okay? It has some sort of digital component in it. So history used analog, but nowadays we're basically digital. Now, throughout history, there were major breakthroughs in technology that helped create these digital devices. So the first one is a transistor. All right. And that was the very beginning or the foundational component. The next one was a microchip. And a microchip allowed a lot of things to happen. The first thing was that it was very small. So when microchips were invented, electronic devices started to get smaller and smaller to basically create like a handheld device. What they also did was create a lot of speed, so devices became faster. And finally, with a microchip, allowed storage. Now, in the late 80s and 90s, CDs and DVDs were started to be created, and this also allowed data storage. In a CD and a DVD can hold many gigabytes of data. Then there was fiber optic cables. Fiber optic cables, along with wireless technology, allowed data to be transferred from one location to another. All right, and that would be binary data. So these are the five major things that really helped contributed to a digital revolution. All right, so why are digital devices important? Well, personal computers, your smartphone, wireless routers, all those are examples of digital devices. And these digital devices allowed things to be created, allowed it to be created very small, okay? And because of this, now there's many different types of digital circuits everywhere you look. So then let's talk about what electrical engineers do. So an electrical engineer is a branch of engineering that deals with electricity, especially the design and the application or how the circuitry is applied. And you see here's some ways that it's applied through generating power, distribution, machine control, and communications. And really, communications nowadays is almost the big one. When your handheld devices, your tablets, your desktop or your laptop, that's all designed by an electrical engineer. So basically, who's going to work with digital devices? Well, electrical engineers are not the only ones who know about circuits. Okay, so there are people called technicians, and technicians are the ones who work on the circuits. They repair, or well, yeah, the circuits and the devices. They repair them, they correct them, they fix them, they troubleshoot them. And then programmers. Programmers are the guys and girls that design the software that gets used by the digital device. And you can see an example of a flow chart here. That's what designers or programmers frequently use to create software or applications. All right. So how is this class different? Well, as I said before, probably in POE you studied electricity and you studied circuits. So why is this course going to be any different? Well, that's simple. Circuit design. We're going to create circuits or design and create circuits. That's how this class is different. And here are two questions that a scientist might ask. What are the laws of nature that make it possible that moving a wire through a magnetic field will generate an electrical current in the wire? That's what a scientist might ask. An engineer asks, I know that moving a wire through a magnetic field can generate an electrical current in the wire. How can I use that knowledge to construct something to address a need? And that's really what we'll be doing. All right. By the way, generating electricity, that's called a generator. All right. So part of my title is cut off there, but that says progression of digital design tools. All right. As I said before, the transistor was the key or the fundamental device or component that really got the digital age started. And then there's a thing called gates. And a gate is exactly what it sounds like. If you have a gate in your backyard, a gate in the backyard might keep out certain things like animals and intruders, but the gate will let in certain people like you or your parents, someone who has a key. So that's what a gate does. A gate's going to let certain things in and keep out certain things. And then the next thing that was created was an integrated chip or an IC. Okay? And we use ICs all the time in here. And an IC chip usually has two sides. All right? This is called the DIP, dual inline pin. So two sets of pin. All right? Again, it's called an IC. And then there's a PLD or a programmable logic device, a PLD. All right? And a PLD we'll get into probably about second semester, and it is exactly what it sounds like. It's a chip that you program and it performs whatever function you tell it to. And finally, this last guy right here, this is called an Arduino or an Arduino board, and it's a microcontroller. All right? And it's basically a microcomputer. It's just a small computer that performs specific tasks. You may have heard of Raspberry Pi. So Raspberry Pi and Arduinos are very similar. They're both microcontrollers. Raspberry Pi is really good at running software. Arduino boards are really good at running hardware. All right. So again, how is this class different? Well, this is a class you're going to learn how to design a circuit. All right? And you're going to learn about the circuit design process. You're going to gain a historical perspective on how advancements in technology and circuit design have impacted the world of electronics. All right? So that's a pretty cool thing. Did you know that binary math was invented about 100 years before the invention of the transistor? So for 100 years we had this binary math that we couldn't really do a whole lot with. Alright, so the final thing, what does the circuit design process look like? Well, we're going to look first at analog circuits. Before we can jump into digital designs, it's important to understand basic circuits, analog components, and analog designs. We're going to talk about what are the characteristics of analog and digital circuits. How are they different? And there's major differences between analog and digital. Finally, we'll look at digital circuits. How do I get the circuit to do what I want it to do? And you're going to do that through combinational logic. You're going to use those gates I talked about. All right? to let in specific things and let out specific things. This is an AND gate. And finally, how do I get the circuit to do what I want? How do I get the circuit to do what I want it to do when I want it to happen? And you're going to use sequential logic for that. Alright? And that is our first PowerPoint.